How you doing there, friends? This is Bill MacDonald, the Common Sense Math Doctor. Come on, sense. We're going to use our 5 senses to teach math today. We're going to look at a 3rd grade readiness problem, which only 51% of the kids in Texas got one like it correct. And I'm going to give you several reasons why today. I'm going to model for you the entire problem. I'm going to use my mathematics chart, my keywords chart, as well as my place value and rules chart to kind of help you prepare your students for the endurance that's needed for multi-step problems like this one. It was basically a guess and check. Your kids had to understand what the word change meant when they were purchasing something. So without further ado, let's go ahead and take a look at the problem. And again, even though some of you are 4th grade teachers, a lot of you, because of my writing friends, I highly suggest that whenever you're looking at my 3rd grade practice tests, and I'm going to show you a couple of them, whenever it says readiness for 3rd grade, that's supporting for 4th grade. And if you take a look at it, the question that was like this one on the 2019 test was question number 21, and only 51% of the kids in Texas in May got it correct. That means when they left 3rd grade, only half the kids knew it. And that was in 2019 before the virus. So if your kids were to take this question, get a question like this one, this past in 2020 or even 2021, because less quality time has been able to be invested in math, I would imagine that the percentage of students that would be able to handle a problem like this would be even lower. So I always say this is not the way to teach a particular problem, but it's a way. So as you know, we all have different rules, and mine are slightly different for math than they are from reading and writing. So I'll just go over them very quickly with you. I highly suggest you teach the kids to read. In reading and writing, it would be reading the question and then the passages, or in math here, reading the question and then the problem. Solo stands for either softly in a testing situation or with a partner, or loudly in a group or class setting. That way, every single kid is seeing the problem and question, saying it, hearing and listening, thinking in their little brains, what strategy do I need? That way I can start executing and writing out the right answer. Once they've read the question and the problem, they will underline so they can understand all of the keywords in both the question and look for and label those keywords and numbers in the problem. Notice that I put brackets because if a number or a keyword starts on one line but doesn't finish until the next line, either have your kids keep on highlighting and then stop, or make a bracket and then stop. That way they can know that this number on this line goes with this keyword or words that doesn't finish till the next line. Then they'll do the E for math. It's evaluating the problem, stopping to think, what strategy do I need, so they can make a plan. Then they'll execute versus ugly their strategies, start eliminating information that's extra as part of that, then eliminating and explaining the wrong answers, selecting the correct answer, searching for errors, and then bubbling in their Scantron or submitting their entry into the computer. Keeping in mind always that odd has 1 vowel and 3 letters. The 2 first odd numbers are 1 and 3. Skip counting 5, 7, 9. All odd will be A, B, C, D. Even has 2 vowels and 4 letters. Skip counting 4, 6, 8, 10. F, G, H, J is for even. Or all low performing questions seem to be having a grid response. Even though we live in an open-ended world, in school, we live in a multiple choice world. So when your kids see a grid response, they have no earthly idea what to do. Now, I think the reason that many of the kids struggled with this one is because of this E, the one we're going to look at. They didn't have the endurance to make it through a multi-step problem like the one that we're going to look at. So I'm going to give you a suggestion for that, okay? Since the question asked which statement is true, I read the question and I read the problem and the chart that went with it. I underlined, I labeled. I'm going to be showing you how to eliminate and execute the strategies to select an answer in the book and the Scantron, okay? Since it says which statement is true, then right away up here, you can put 1 T and 3 Fs to remind your kids you're going to do what's called guess and check until you find out which one of the 4 statements is actually true and which ones are false. Now, let's go ahead and read the problem, and then we'll start reading the questions. 4 friends, here they are, Jeff, Martha, Carmina, and William, went to a carnival and each purchases some tickets for the rides, okay? So there's the cost of the tickets for each person. They all don't buy the same amount of tickets, and they all purchase. Now, what I want you to notice, the students gave dollar amounts that were ending in 0 cents. So if the state wanted to try and trick your kids, remind them that $20 is the same thing as $20 and 0 cents. $30 is the same as $30 and 0 cents, because whenever you're subtracting to find out how much change, which is going to be this problem's keyword, kids are gonna have to remember that there's 2 zeros, 0 dimes, and 0 pennies in the tenths and hundredths column. Carmina had $15 and 0 cents, and William gave them $25 and 0 cents. So he probably gave a $20 bill and a $5 bill, or 2 tens and a 5. Carmina gave probably a 10 and a 5. Martha gave a 20 and a 10, or 6 5s, or 3 10s, and ask your kids how many different ways could Jeff have given his money, even including $1 bills possibly. So the next thing says the table shows the amount of money that each child paid. There it is. The cashier and the total cost for the tickets. So each child, the total cost of the tickets, how much each paid. Tickets are different prices depending on the type of ride and include the tax that the carnival charges. So you don't have to factor in that. Now, let's find out what it says here. It says Jeff will receive $38.58 in change. As soon as I see that word change, I need to think about my mathematics chart, and I've written it in there for those of you that by the 3rd, 4th, 5th, 6th, 7th, or 8th grade math problems. Let me show you, not the rules part. If I flip it over, if I look in the subtraction section, it says how much something, and you saw a video last week about something you subtract. Well, if it's how much change, we're also going to subtract. So I noticed on the real test that year, besides not being able to have the endurance to work out 4 subtraction problems where they're all 4 subtracting across zeros, and it's so easy to make a mistake with that, I'm going to show you an easier way to subtract across zeros. The other thing is that because change means you subtract, look at letter A, it says plus. the amount given for Jeff, $20, plus the cost of his tickets is true. That's $38.50. But change, how much change you subtract, you're never going to get more money in change than you're actually giving to the cashier. So probably some of the kids got the answer wrong, because it's possible that if they throw in this distractor, because this statement is true, when you do add up those two numbers, it's true, but it says he's going to get that much in change. Yes, this part of the problem, part of the letter is true, but no, that part's not going to be what he gets in change. And so I would cross that off, because how much change you subtract, not add. So we're going to eliminate letter A right away. Martha will receive $8.25 in change. How much change you subtract, because the amount given, and so we can actually underline and plug in here that we can see, oh, $30 and nothing else is what Martha gave, minus subtracting, subtraction sign, the cost of her tickets, $22.75 is equal to $8.25. So we'll check and see if that's true, because we did subtract here. Carmina will receive $2.25 in change. How much change you subtract? There's the subtraction sign. The amount, her amount given, $15.00, minus the cost of her tickets, $12.25, is equal to $2.25. We will check and see if that is true when we subtract these two numbers, one from the smaller one from the bigger number. Okay. William will receive $3.01 in change. How much change you subtract? Does it have subtraction? Yes. The amount given for William is $25.00, 0 dimes, 0 pennies, minus the cost of his tickets. And again, like I said, if you make an opening bracket or highlight, cost of the tickets is what they were talking about. It's $21.99. So what a lot of people like most about my mathematics chart, it allows you to play guess and check. At the school I was at last week, every single teacher has enough of these for her entire class. And so we were checking, since that's an number 5 is an odd number, our choices are A, B, C, D. We've already decided that A is false because of the keywords needing to be change, minus. We're not going to be plus, we're not going to be adding to find out change, because your number that you give a cashier has to be lower, has to be higher than the amount of change that you're going to get back, because they're not going to give you back more money than you actually pay. So here's letter B. Letter B said $8.25 in change. So we're going to check and see if that's true. So here is the whole numbers. And with whole numbers, we have commas after each period, billions, period, then comma, millions, comma, thousands, comma. I call it the no-name family. And when I open it up, you can say your keyword, dollars, and then we'll get into the cents. So it said $30 and no cents, minus $22.75. Well, a lot of you are having your kids do the old style regrouping, and then borrowing, and then regrouping again. Well, think of it like this. If I have 0 pennies and all I need to do is borrow 10 pennies, because that's what you do, is borrow 10, I've just got to borrow 10 pennies. Well, since there's no dimes, tenths, there's no dollars, there's only a $10 bill. Well, $30 or 300 dimes is what we do have. And so if you borrow 1 dime from 300, you'll have 299 dimes. And then you could move that dime over to the penny column and say, since I borrowed 1 dime from the 10th place and having to borrow from the dollars as well, the dime becomes 10 pennies. 10 take away 5 is 5, or 5, so subtract 5 from 10 is 5 cents. 5% of a dollar, 5% of a dollar. 9 take away 7 is 2, and 9 take away 2 is 7. So the answer, the change, how much change would be $7.25. And notice that when I'm subtracting, if you make a circle around the decimals, that will help your students keep them all in a straight line so that the subtraction is done with the correct number. So let's check and see. Is $7.25 the same as $8.25? No. So that would be our second false statement. So we're going to eliminate letter B. Letter C said, for Carmina, she gave the cashier $15 and no cents. Her cost of her carnival ride tickets were $12.25. Once again, we get to have extra practice on subtracting across zeros. And again, it's not the way, but a way. Since I don't have any dime pennies, I don't have any dimes, I have dollars. So what I'm going to say is, okay, I have 150, that's 150 dimes. If I lend 1 dime to the pennies, the dime that comes before 150 is 149 dimes. When we borrow 1 dime, it becomes 10 pennies. 10 take away 5 is 5 cents. 5 cents means 5% of a dollar, 5% of a dollar. 9 minus 2 is 7 dimes, and 75 cents is how you would say that, or 75% of a dollar, or 75% of a dollar. Make sure your kids know how to say that different ways. And then 4 take away 2 or subtract 2 from 4 is you get $2. So the answer is $2.75 is your change. So we'll check and see, is $2.75 the same as $2.25? No. So letter C is also false. So here's the issue. Since many kids don't have the endurance to go through all 4, then the first time what you're going to do is you'll do letter A, or in this case, letter B with the whole class, because you're going to teach them that A will be eliminated right away because we wouldn't be adding to get change, we would be subtracting. So if you did letter B with your whole class, you could have them divide up and say, okay, this group, these teams do letter C, just C, and these teams just do letter D. And then instead of doing all 4, they only have to do 1 with their group, and they don't have to do any by themselves or with a partner. Or you can say, let's do this one as a class. We'll do this one in groups. We'll do letter C with a partner, and we'll try letter D on our own. And the good thing about letter D on our own is it's the only one that's the correct one, because when you do subtract, it does come out correct. Watch. That the last person, I think that was me, William, my real name, gave the cashier $25, but the cost of his items was only $21. And circle my little highway of decimals there, and decimal means and, $21.99. So how much change you subtract, I have 0 pennies, 0 dimes, but I do have $25. I have $25, but I also have 0 dimes. Well, $25 is 250 dimes. So if I borrow 1 dime, it becomes 249. 1 dime lent to the pennies becomes 10 pennies. Minus 9 equals 1 penny, 1 cent. 9 minus 9 is 0. Subtract 9 from 9 is 0. That's 1 penny or 1 cent or 1%. 1 penny is 1% of a dollar. 1 penny is 1% of a dollar. And then we have 4, take away 1 is 3, or subtract 1 from 4, we get 3. So our change, 2 minus 2 is 0 when we, because of having to borrow 1 dime. $3.01 is our change. So we'll check and see, D, does $3.01 equal $3.01? Yes. So the answer we're going to pick. And then because this is a dry erase marker or a wet erase, you can use probably the finer points. This is the one that I'm using. I use a Sharpie, and then I just use like wet wipes or some sort of rubbing alcohol or something that'll clean it off pretty quickly. So let's check our answers. The only one that was true was letter D. So we did select D. We bubbled it in, pretending like it's the Scantron. Because we were doing this possibly as a class group and with partners. Hopefully everybody's checked everything to make sure it's true. Remind them about change, how much change you subtract, and we'll eliminate letters A, B, and C, and then right next to number 5, we'll put a little D, so that the 5D in the book matches the 5D in the Scantron or the submission that you select in your computer response. Now, keep in mind that book answers have to match computer answers. Your book answer has to answer the answer you submit. So if you think of submit and Scantron and select, well, that all starts with an S. So does the word shoe. And since your left shoe always matches your right shoe, tell your kids to think of your book answer as one of the pairs of matching shoes, and your submission or your Scantron paper answer, bubbled answer that you bubble in, would be the other matching shoe. So the 5D in the book has to match the 5D in the Scantron or the 5D in the submitted response that you put in the computer. So yes, this was a 3rd grade problem, but you can see that many 4th, 5th, and even 6th grade students would have trouble because this is basically a 4-step problem involving subtraction across zeros 4 times. If the students try to subtract accidentally, the change, if you have them practice one more time, the change would have been $1.50. So if they would have said that Jeff would receive $1.50 in change, that would have been, had to have been changed, and the amount given plus needed to have been changed to minus in order to make that statement true. But a lot of kids probably got that wrong because of only half of the statement being true, or because they did not have the endurance to do several problems. So build their endurance by only asking them to do 1 letter, and then a few weeks later ask them to only do 2 letters, then 3 letters, and then they can build their endurance to all 4 letters. God bless you guys. I will go ahead and make a link. This is in YouTube. Look at the description portion of this YouTube, and I'll make a link to the 3rd grade and the 4th grade difficult problems from 2019. I will be putting in the 5th, 6th, 7th, and 8th grade as well. 8th grade, I only have it for certain years because I just want to be real honest with you guys. I don't normally work with 8th grade math because they allow students to use a calculator. And many of you are allowing students to use the calculator too early in the year. And if you use, this is kind of corny and gross, but if you use too much calculator now, you get caca later. And by that, I don't mean to be silly or gross. I just mean that your kids won't be able to do any pencil and paper work because they'll rely so heavily on the calculator that very simple operations will not be able to be performed because they're so heavily reliant on their calculator too. So email me at writing_doctor@yahoo.com if you have any questions. I would love to do training with you in your campus this summer on math with my Common Sense math program, where everybody gets the posters and the graphic organizers and all the practice tests that I've made, and showing you just different ways to solve very difficult problems. Please share this video if you are a teacher who has students or colleagues who have students who struggle with subtraction across zeros or doing multi-step problems. In this case, it was technically a 3-step problem if your students would have noticed the word plus. Thank you guys. Don't forget to click like on the video and tag or share it with your writing teacher friends. God bless you guys and have a wonderful day.